Assalamualaikum and good day to my students. Okay, for this week we will move to new topic which is AC power analysis. Okay, as far as your concerns, we have deal with previously we have deal with calculating the voltage and current in AC analysis. So we move on to this chapter. So our major concerns is to evaluate and analyze the power in AC circuit. Okay, so before I continue with the objective of this chapter, so let me explain a little bit about power. So power is the most important quality in electric utilities, electronic and communication system because all these systems involve the transmission of power from one point to another. So you know that in every industrial and household device has a power rating, okay, that indicates on how much the power for each equipment is required. So when you exceeding the power rating, okay, your appliance or your device, you know that it will be damaged. Okay. So the main focus for this chapter, okay, we will deal with average power, instantaneous power, power factor, and complex power. So for average power, we will calculate either the average power is delivered to or the average power is supplied from a pair of terminals. So either than average power, so other measurements of power will involve the instantaneous power, okay, the complex power which includes the reactive power, apparent power, and also the power factor. Alright, let me begin with instantaneous power. So what is instantaneous power? Okay, as a definition, you know that previously in you have learned in circuit theory 1, P equals to IV or equivalent to P equals to VI. Okay, so for AC analysis, since you deal with voltage in cosine or sine, okay, the instantaneous power is product of the instantaneous voltage across the element and the instantaneous current through it, where PT equals to BT times IT. Okay, you know that previously we have learned that BT equals to Bm cos omega T plus theta. So we label it as theta V for voltage, and IT is equals to Im cos omega T plus theta I. So the angle for current is theta I. Okay, so what is Vm? Sorry, what is Vm and what is Im? Okay, Vm and Im, as you learned before, okay, is the amplitude. Okay, we will not deal with the voltage in RMS first, so we call it as amplitude voltage. And the units for the instantaneous power, okay, is still what? Same as you learned previously. Okay, unit is watts. Okay, when you calculate the instantaneous power, okay, we include the value of Vt and value of It. So the instantaneous power Pt will get this equation. Okay, Vm Im cos omega t plus theta v times cos omega t plus theta I. So this one will difficult to measure because you have two cosine in one equation. So we have to solve the equation using trigonometric identities. Okay, when you solve the equation, it will give equation 1. Okay, half Vm Im cos theta b minus theta I plus half Vm Im cos 2 omega t plus theta b plus theta I. And when we plot the waveform, okay, for this equation, okay, it will get half positive positive wave is half VMIM and negative cycle is half VMIM cos theta v minus theta I. Alright. Okay. So when you calculating the power, okay, you will deal the power in positive value or negative value, where the positive power we call as a power absorbed by the circuit, and negative power is dissipated from the circuit. Okay, so from this equation, it is difficult to measure. Okay, so from this equation, okay, it is difficult to measure the instantaneous power. Okay, so how to solve this problem? Okay, we move to average power. So average power as a definition. Okay, so we will integrate this instantaneous power. Okay, P equals to 1 over T integration of PT. And we substitute that equation into this equation. Okay, you will get two components of power. So which is a constant and in sinusoid component. Okay, so by the definition, okay, so the constant equation we call is an average power. So from the definition, so average power is the average of the instantaneous power over one period. Where P average, okay, you have to label the terms of average power as PAVG. Okay, average power is equal to half VMIM cos theta B minus theta I, or it is equivalently as half VMIM cos theta I minus theta B. Okay, so you noted that from the average power, okay, the equation is not depend on time. It has just the amplitude, voltage, and amplitude of currents, okay, times with the multiply with the cos angle of current minus angle of voltage. Okay, so this value will get the constant value, and the unit is in watts. W. Alright. So when we deal in circuit analysis, okay, we have element of resistor, element of inductor, and element of capacitor in the circuit. Okay. So previously, you learned that when we plot the voltage and current, okay, if the voltage is in this blue color and current is equals to IT, okay, you know that there is no phase shift, okay, no phase shift between the voltage and current in resistor. This one is in resistor. Okay, so in resistor there is no phase shift, okay, between voltage and current. So since the equation of average power is half Vm Im cos theta V minus theta I. So as in resistor, the angle for voltage is equals to angle of current. Okay, since the angle is equals, so cos theta V minus theta I will be 0. Okay, if you calculate using your calculator, cos 0 is equals to 1. Okay, since theta is 0 and cos theta equals to 1, okay, so the average power in resistor is equals to half VMIM. Okay, so the equation just half VMIM. Okay, so you know that in Ohm's law, okay, V equals to IR. Okay, you can substitute VM as IM times R. So from half VMIM, so you will get half IM R times IM. And it will give you half IM square times R. Or as you know that the amplitude is a magnitude of the current. Okay, you can also calculate as this one without insert the angle for resistor, or you can also include since IM is equals to VM over R, VM over R. Okay, so this equation for power, average power in resistor, you will also can calculate as a half VM times VM over R. Okay, is equals to half VM square over R. Okay, this one is average power in resistor. So for resistor, a resistive load absorbs power at all times. Okay, from this equation. Okay, in inductor and capacitor, okay, so you know that the voltage and current in capacitor and inductor is either leading or lagging, okay, by 90 degree. Okay, you in chapter 2 have mentioned about this one. Okay, either the capacitor is leading or lagging, or the inductor is leading or lagging by 90 degree. So you will have a purely reactive circuit if the circuit consists of inductor and capacitor, because when the angle for inductor or capacitor, okay, you have a difference of 90 degree. Okay, and you will calculate, if you calculate cos 90 degree, it will equals to 0. So average power for inductor and capacitor will equals to 0. Okay, or we call as reactive load for inductor or capacitor absorbs 0 average power, and the circuit will have a purely reactive circuit. Okay,